So we're going to start off by, as a class, developing a unit circle together as fast as we can, although I ramble. When you take your unit circle quiz, it'll be Monday at the very end of the hour. I'll give you exactly 10 minutes to make it happen, and that's the time you get, okay? So, you should come up with a plan of attack on your own. What works better for you? I am awful at memorizing things, so I have to conceptualize everything. So this would be if you struggle like a bruiser. I start with what makes me comfortable, so that way I have markings that I can kind of reference back to. So I start with degrees, and I specifically might start with the quadrantals, but I think I can handle pretty much all of these. So this is 0 degrees, 90 degrees, 180 degrees. What's this guy? 270. And then if you come all the way back to a full circle, you're back at 360. Now the other thing I do as I develop the unit circle is I use colors to indicate the families, because that kind of helps me with what goes together. So I'm going to continue to mark my angles, but I'm going to switch colors as I go. So what's this next degree? 30, and then after that would be a 45, and then we got a 60. We already have the 90. Okay, feel good there. What comes next? 120. 135. Oops, I switched colors wrong. And then 150. Thank you. Got 180 there. That's the right spot. Cool, cool. Keep going. 210. And you guys are remembering, in case you get stuck or panic in the middle of your test, the larger looking triangle angles are 30 degrees, and these teeny tiny guys are 15s. So next would be 225, 240, which brings me to 270. Awesome. Keep going. Yeah. Which brings us back to, oops, yes, you said it. I wrote it wrong. 330, which brings us back to 360. Whew. All right, one thing down. Now, up to you what you do next. The hardest part for me is the radians. It just is. So I start with the radians I'm comfortable with. I'm very comfortable with the quadrantal radians. This is 0 radians. Do you remember what this guy is? Yeah, pi over 2. And this one is pi. So it's counting by halves, right? So 0, 1 half, 2 halves. This is 3 halves pi. And this brings you back to 4 halves pi, better known as 2 pi. All right, feeling good. Again, up to you where you go next. I like to handle the 45s family because I can count pretty easily by splitting the quadrants in half. So remember, pi over 2, this is halfway to that, so this would be pi over 4. So what's tricky about the pi over 4s family is you can't forget that they have cousins. So like pi over 4, pi over 2 is also technically a pi over 4 family. So 1 pi over 4, this guy is 2 pi over 4, so this next one must be 3 pi over 4. This next one here is 4 pi over 4. So this must be 5 pi over 4. This one we already have, but is it 6 pi over 4? And then this last one must be 7 pi over 4. And technically I could keep counting to 8 pi over 4. Does that match up where I need to be? Which is 2 pi. All right, cool. All right, for me, I go to the 60s next. Because the 30s family, there's a whole lot of them on here. And if I can kind of limit how many things I got to fill out at the end, I'm going to be happy. So, just for some weird reason in my brain, I just remember that 60 and pi over 3 go together. Like many things in math where I feel like things are opposite. But you could, if you got in a jam, do a quick conversion on paper. You don't get to use a calculator at all for this test, so keep that in mind. And you don't really have time to do a lot of converting, so you got to know it. So now this is why I'm using the colors. His next buddy would be over here. So this is 1 pi over 3. This guy must be 2 pi over 3. Now be careful. This is technically a cousin of this. This is 3 pi over 3. But that's okay, because that's where it's supposed to be. So this one must be 4 pi over 3. This next one must be 5 pi over 3. And then the final cousin is 6 pi over 3, which is totally 2 pi, which is exactly where it should be. Whew. All right, almost there. For me, this is the most annoying part. All right, 30 degrees, better known as pi over 6. So this is where kids get irritated because there's a lot of hidden pi over 6s in here. Instead of counting every single pi over 6 and its cousins, I just back up and go forward pi over 6 units. I think about fractions, right? So like pi, if you want to think about common denominators, is like 6 pi over 6. So if you were to back up 1 unit of pi over 6, that means you're at 5 pi over 6. But with the same idea, if you're at 6 pi over 6 and you move forward 1 more, you're at 7 pi over 6. Same thing over here. 2 pi is really the same thing as 12 pi over 6. So if you were to back up 1 unit of pi over 6, you'd be at 11 pi over 6. Now, the other option, and hopefully some of you are to this point because you just had a season of trig, maybe you just remember them. Some people just have really good memories and they're like 11 pi over 6 is right there. I don't really know why, I just know it's there. For now, that's fine. If you have that kind of memory, you are a blessed child. I do not. Because between the dyslexia and just the fact that I have no memory, I'm going to screw it up. So I have to conceptualize everything I do. Alright, so in my opinion, that's the hardest part. The part that kids sometimes forget to fill out, though, is who's positive and negative in each quadrant. So there's a mnemonic device that helps you with who's positive and who's negative. Do you remember what it is? All students take calculus. Yep. So this quadrant number 1, we write down an A, and then students take calculus. What does A really stand for, though? Literally stands for all the trig functions are positive. So positive, you don't need to list all of them out, guys. Just write all. And write none. Now, for this quadrant, quadrant 2, I don't have room to write, my handwriting's too big. So I'm going to go over here, I'm going to write plus. Who's positive in quadrant 2? Sine, and who else? Cosecant, very good. Who's negative? Can you list them for me? This one I do want you to list them out. Tangent and his buddy cotangent. And cosine and his buddy secant. The reason I do want you to go through and list them out is because it's going to help you later when you have to keep in mind that cosecant and sine are reciprocals and they go together. It's going to help you out in the future. It won't kill your time, I promise. All right, this quadrant, quadrant number 3. Who's positive? Tangent and cotangent. Who's negative? Yeah? Cosine, secant. You got it. Oops, you said the right thing. I can't write the right thing. And then the final quadrant, quadrant 4. Who's positive?
Cosine.
Yeah. And secant. Who's negative? Look at you. You're like a little trigonometry robot. I like it. You must have loved your experience in trig. Alright, nice job on the memorization, Taylor. Okay, here we go. This is where there's a lot of cutesy tricks and stuff as to like which trig functions have what. Before we get to that, I'm just going to fill out the ones that are very obvious to our logical brains. The quadrantals should be very obvious. Unit circles are called that because their length of distance that you're traveling on the radii is 1. So this ordered pair right here would be moving over 1 unit and up nothing. So the ordered pair, which is cosine sine, we'll come back to that in the lesson today, is 1, 0. But this quadrantal up here, that would be moving over nothing and up 1, so that would be the ordered pair 0, 1. This ordered pair is moving left 1, so negative 1, 0. And then this quadrantal is 0, negative 1. Okay, makes sense to my coordinate plane brain, which we've been working with since we were wee little ones. So now I fill out the one that I think is the easiest for me after the quadrantals. For me, that would be the pi over 4 family. Because the 45, what's really happening is you guys have a 45, 45, 90 triangle. So you have an isosceles triangle where your x and y, or your cosine and sine, are the same thing. Do you remember what they are? Yeah, square root of 2 over 2. I'm going to go fill out all the green parts. You guys got to help me with signs, though. And you can either go back to what Taylor rattled off already, or you can just think of this as an ordered pair. Think about moving over to the left and then up. Which part of this ordered pair is negative? The x value, yeah. So this is negative square root of 2 over 2. Square root of 2 over 2. But down here, at this green guy, they're both going to be negative, because it's left and down. I know it looks really sloppy right now. I'm apologizing. And then this final green guy, we're moving to the right and down. So your x value is positive, but your y value is negative. Oops, I need to write negative. There we go. Whew. So now the part where kids start to freak out. Because they're like, oh gosh, one of them square root of 3 over 2, and the other one is 1/2. Real quick, I'm going to back up a moment. Yeah, that might work. This red stuff here, this is a triangle for a 30-degree angle, right? That's the first one on the unit circle. If you think back to our work yesterday with the 30, 60, 90s, the little leg is supposed to be a value, but the hypotenuse is double that value. But remember, we said the hypotenuse, or the radius in a unit circle, was always a 1. So how big is the little leg if he's half of that? He'd be a 1/2. And then the medium-sized leg, the one that's across from the 60-degree angle, is whatever the littlest leg is times the square root of 3. So if you took a 1/2 and you multiplied it by square root of 3, you'd get square root of 3 over 2. So if I think about this ordered pair right here, it is moving over square root of 3 over 2 and up 1/2. So here's where I don't want you to develop a 30, 60, 90 every time, because I think somewhere in your memory you have square root of 3 over 2 comma 1/2 memorized. You're just not sure which order it goes in. Think of it this way. This triangle at 30 degrees moves over a lot farther than it moves up. The horizontal distance is larger. So which number is larger, square root of 3 or 1? Square root of 3. Square root of 3, if you compare square root of 3 to square root of 1, that guy's going to be bigger. Because 1 is square root of 1, right? So in this case, if you're like, oh, I can't remember which one goes first, you can conceptualize it that way. Now, when I was a wee little one trying to memorize this, I had all sorts of tricks. I was like, the 30 and the square root of 3, like, so, I don't know, something in my brain, like, put them together, but then all of a sudden I'd panic and I'd be like, wait, was it pi over 3 or 30? Is it pi over 6 or 60? Is it... This is what dyslexia does to you, right? So you have to start coming up with ways to memorize it. Have you guys heard the 1, 2, 3, 3, 2, 1 thing? That trick? Okay, I'll talk about that in a minute if you haven't heard about it. All right, so we just decided that 30 degrees, the ordered pair here was, oops, that is not blue, is square root of 3 over 2, comma 1/2. So all the blue guys now I can fill out, I just got to watch my signs. So like over here, I'm moving to the left, so this would be negative square root of 3 over 2, comma 1/2. And then this guy down here, they're both negative. And then over here, the x is positive, but the y is negative, or the cosine is positive, but the sine is negative. All right, we're almost home free. Last one. Remember how 30 and 60 are related to each other? They're the same triangle. They just have the reversed ordered pair because they have the other angle that they're referencing from. So instead of square root of 3 first, it's 1/2 first. All right, everything filled in with my signs next, and then I'm good to go. Remember, no calculator, no reference when you take this unit circle test. And little time. 1/2 negative square root of 3 over 2. All right, here's the 3, 2, 1, 1, 2, 3 trick. Let me show you what I'm talking about. So this trick doesn't work for me because I have to remember things. But if you look at the numerators of the x values, and you start at the top here. It goes 1, 2, 3, and then you start looping back. 1, 2, 3. And then some teachers take it further and they go, and then you put square root symbols over each of them. So that confuses kids for some reason because they're like, well, what do you mean? There's no square root symbol there. There kind of is. What's the square root of 1? It's 1. So they just simplified it, right? Square root of 1, square root of 2, square root of 3, square root of 1, square root of 2, square root of 3. So if you're like in the middle of your test and you're having a second guessing moment like I always have, like my entire life, sometimes it helps to remember things like that. 1, 2, 3, 1, 2, 3. Start starting at the top-ish of the quadrant and moving down and then looping back. Okay? Because what happens if you get those reversed by accident? You're going to probably reverse them all throughout the unit circle. Now, that's not the end of the world. you're going to get a 3. It's not like I'm going to take off like 40 points because you got a bunch of things wrong. But if you get them wrong in the first quadrant, but you don't continue to get them wrong in the same fashion, and you get something else wrong later on in the unit circle, then you're going to get knocked down to it too. Okay. That's the unit circle. So with all my blabbing, it took me more than 10 minutes. I'm sorry. You guys will be better than me, I know. Could you find your notes? And I think it's on worksheet 8. We're going to be using the unit circle now. So on your test on Tuesday, that's just a normal summative, and you get to use the unit circle for reference when we do these questions. So we're going to keep that in mind. Alright, so have your blue reference sheet handy because we will be referencing it a few times, and we'll be looking at the side that has a unit circle. No, homework check will be due for Tuesday's test. We're going to skip the warm-up because I'm a little worried about time here. We already did special right triangles. Go us. All right, here's the beginning of our notes. So they're going to use your knowledge of the coordinate plane in order to use the trig functions now, because really the unit circle is just an elaborate-looking coordinate plane with trig functions on it. So any point drawn, you can create your trig functions because you can create triangles. So these formulas here, you're going to have to memorize. The good news is you kind of already know them because they make a lot of sense. I'll show you what I mean in a second. The other formula that's snuck up here is right here. It says r equals the square root of x squared plus y squared. Does that look like any formula you know? Kinda. Doesn't it look like Pythagorean theorem a la distance formula as well? Yeah, it is. And I'll show you why. So they drew a terminal angle, or an angle with a terminal side over here. And in doing that, you can create a triangle. And we'll talk about this vocab word in a second, but your triangles are always going to be drawn in reference to the nearest x-axis because we're going to use this guy right here as a reference angle. So in general, if I have an ordered pair over here, that means I have a horizontal distance that it's measured over and a vertical distance that it's measured vertically. And then you could find the hypotenuse of a triangle by doing Pythagorean theorem. So they call it r because in trig land, we refer to the radius of a unit circle as being r. Okay. So now if I think about that triangle and I think of this as being my reference point, if I asked you to set up a ratio for cosine, well, the little kid formula is adjacent over hypotenuse, but now the big kid formula is x over r. And then for sine, it's opposite over hypotenuse, but the big kid formula is y over r. So it's all the same formula, but because we're going to be dealing with coordinate planes and ordered pairs, man, it sure would be nice if you could just have this shortened looking formula. You don't have to draw a triangle every single time. The other thing we want to bring to your attention, you might want to jot this down on your notes somewhere, although I think it's in your memory because we just talked about it. The ordered pairs are cosine comma sine on the unit circle because x goes with cosine and y goes with sine. And remember on the unit circle, the radius is 1. So like when you take x and divide it by 1, you just get x. That's why it's cosine. Okay. All right. So this concept, this is called a reference angle. A reference angle is measuring, so once you measure an angle and it has a terminal side, you're going to measure how far away you are from the x-axis. You might want to write yourself a note that they are always positive. So I like to think of them literally as measuring the distance to the nearest x-axis. So if this guy right here is your terminal ray, then your reference angle is this measurement right there. But if like this angle gets drawn, so like it starts here but it ends here, your actual reference angle is this guy right here, the distance to the nearest x-axis. So again, this guy, if we drew this ray, so this angle would be like, 200 and something. His reference angle is only this distance from here to here. And the same thing over here. It's the nearest x-axis is what you're measuring to for reference angles. Okay. So even though the angle itself looped around, the reference angle it's going to be an acute positive angle. All right. So I'm a visual person, guys. So whenever I get these questions that really feel like ordered pairs or coordinate plane questions, I'm always going to draw something out for myself because I like to confirm that I'm not having a dyslexic moment and doing something stupid. So the only thing that gets weird is when you have what's called a quadrantal angle, which are the guys that are on the axes. You can't create a reference angle. You can't create a triangle from an axis. So we're going to see a question coming up where it's like, what's the reference angle to, 90 degrees? And the answer is there is no reference angle to 90 degrees. It's a quadrantal. So this question, they want you to sketch the angle and find the reference angle. And we're going to use the same notation, everybody. All right. So you do have to sketch it. Here is your beautiful coordinate plane. And you got to think about where 330 degrees would land. Remember, when you're taking this test, for now, you do have that blue reference page to look at. I think you kind of know where 330 degrees is, don't you? It's like staring right at you. It's right here. So here's what I need to see from you. I need to see a terminating ray where 330 degrees is located. The other thing I need to see from you is called a directional arrow. You started in standard position and you opened up positively, so I need to see this from everybody. I also need to see the number 330 degrees somewhere on your page, near that angle. Okay, there's one more question. What's the reference angle? They use this symbol, it's called alpha, looks like a little fishy, it's a Greek letter. It's the distance to the nearest x-axis. So how far away is this guy from the next, oh, I didn't write 0, thank you. That's what you're saying, huh? There we go. How far away are you to the next x-axis? 30 degrees. And notice how you guys are telling me 30 and not negative 30 because reference angles are always positive. They're always positive and always acute. Now there's a little note underneath that direction set. It says if the angle is in degrees, your answer must be in degrees. If your angle is in radians, your answer must be in radians. Well, number 2 is a big bummer. Not only is it in radians, it's a negative radian. So now I'm like, well, great, that's wonderful. So you have to decide how you want to approach this question. You can convert it to degrees and then just make sure at the end of the problem it comes back to radians. You want to do that? And when I say convert, I use that very loosely because 3 pi over 4, that's something on your unit circle. It's one of our special angles. Negative 3 pi over 4 is the same thing as negative 135 degrees. I'm way more comfortable graphing a negative 135 degrees. So I'm going to go ahead and do that. We'll do the converting in a moment. All right, negative 135, this time is going to measure negatively, but he's going to stop like right in the middle of this quadrant, right? So I'm going to draw that terminal ray. I'm going to show my teacher the directional arrow, and this is where I get crafty. I'm just going to pretend like I totally knew that was where negative 3 pi over 4 was. Because I totally did. Not. Maybe. Now this is where it gets a little crazy, but maybe not. Remember, I'm looking for distance between here and the nearest x-axis. Well, think about 3 pi over 4 and who that really is. It's the 45s family, right? So how big is this angle? 45 degrees is your reference angle. Nice job. Notice how Miss Taylor told me 45 and not negative 45 because she remembers reference angles are always... Oh, but what did I do? Dang it! See, I'm going to get it wrong. What's 45 degrees in radians? Very good. Pi over 4. My friends who are exceptionally good at fractions did this a little differently. They maybe measured their quadrantals negatively. Maybe they called them like, well, this is 0 still. This is like negative pi over 2. And this is negative pi. So 3/4 pi would be smack in the middle of half and 1. And then they're really good at fractions. Go you. So they're like, oh, 1/4 pi. I'm not. So I just got to work with what I got sometimes, guys. And worst case scenario is if you don't even have a reference page in front of you, you could just straight up convert it to degrees. Hopefully that is memorized for you. But there's always ways around it. The problem is time, right? Like if you're going to run out of time doing all those little fun things, then you're going to be in trouble. Yes, Jacob? So in that case, we have one coming up. There's no reference angle. You can still draw it for me, though. That's a great question. Like number 3, 9 pi over 6. At first I was like, what? And then I realized that reduced. What's 9 pi over 6? That's 3 pi over 2. So this is a good example. Man, you're like prophetic. 3 pi over 2, where is it? Right here. So I'm still going to show my teacher how I got there, directionally, I moved like this. This is 3 pi over 2. But as far as reference angle, there is no reference angle. Because it is quadrantal. Fun word for your day, right? Quadrantal. All right, 11 pi over 6. That's a unit circle friend, isn't it? So I'm probably going to cheat a little bit with my blue formula sheet. 11 pi over 6. Remember, he's right here. So I'm still going to have to show my teacher how I got there. Directional in the positive direction. That is where 11 pi over 6 is. But I need your reference angle measured in the proper notation. So for us, that would be radians. So how far away is it? Pi over 6. Very nice. Notice we got a positive pi over 6 answer. Reference angles are always positive. Okay, 165 is not on the unit circle. Good news is it's in degrees. So I think about 90, 180, 165 would be like right here. I got to show my teacher I measured in the positive direction. And then this just becomes a cute little subtraction problem. How far away is it from the 180? 15 degrees. Reference angle of 15 degrees. Man, 6. They must like hate us or something. Negative 5 pi over 9. Okay, it's radians, it's negative, and it's not even 1 from my unit circle. So that is very awful. So I don't know about you guys, but I think I'm just going to convert it. So let's talk about what negative 5 pi over 9 really is, because my brain can't handle radians today. I'm going to convert it by doing pi over 180 over pi. The pi's will cancel. Let's see, this is a 20, so what is that, negative 100 degrees? So this is the same thing as negative 100 degrees. Cool. Let's draw that. But remember, we're going to cheat and name it what it's really supposed to be named. So negative 100 degrees would be just past negative 90, so like right here. Got to show my teacher that I moved negatively, and this is where I get crafty. Don't call it negative 100, call it negative 5 pi over 9. She'll never know the difference. Who's this mean teacher we talk about? Okay, now, this is where we might deviate in our approach. I need to figure out how far away I am from the nearest x-axis. For some of you, you're totally fine by just saying, well, if I'm measuring negatively, this is like negative pi right here. So I just got to figure out how far away 1 pi and 5/9 pi are from each other. And the answer is 4/9 pi, I'm done. You're a very good fraction wizard. I'm not that good, okay? So what I'm going to do is I'm going to go back to my cheating moment. Remember how this was negative 100? That means it was 80 degrees more to get to the next x-axis. So I know the reference angle is secretly 80 degrees. But my teacher doesn't want to see 80 degrees. She wants to see radians. So then I have to go back, and I'm going to have to convert it back to radians. And that's how I'm going to get 4 pi over 9. So yes, it's going to take you longer if you have to go back and convert between the systems. So on your test on Tuesday, that's a sacrifice you're willing to make, maybe, if you end up with a question like that. That's an awful question. If they're not from the unit circle, then everyone gets very sad, and you got to think really hard. Okay. Just remember and be careful that your reference angles are always positive, and they're always measuring to the nearest x-axis. So this question here is done for you. Let's move on. So we have one that's not done. We have a random xy ordered pair, and we're going to find our 6 trig functions. And I would like you guys to use your new big kid rules. So one thing I'm going to have to figure out is the radius length, the r, and that's using Pythagorean theorem. So 2 squared is 4, negative 5 squared is 25, which means the radius length is the square root of 29. So 6 trig functions. I need sine and cosecant. I'm going to skip number 8, by the way, if you need room. I need cosine and secant. And I need tangent and cotangent. Now, if you're a visual learner, that'd be me. The other thing I'm going to do, I'm going to draw myself what's going on here. I'm going to draw what looks like a triangle at x equals 2, y equals -5. So, yep, sure, right there. And I'm going to do something that's highly illegal, but I don't care. I'm going to label my triangle legs, even though some of them are negative. So, like, this is a 2. This would have been a down 5. I know that's stupid to call a triangle leg -5, but I'm doing it anyways. And y'all just found the radius or the hypotenuse to be the square root of 29. The reason I'm going to write that down on my paper is in case I forgot one of my formulas for tangent, sine, cosine, whatever. Because now I can go back to a little kid formula if I have to. Remember, the angle that you are now referencing is from your reference angle right there. So again, go back to the picture if you have to. But it would be nice if you have it memorized. Sine is y over r. So you're going to start off with -5 over the square root of 29. And then your teacher's going to make you rationalize that. So that becomes -5 squared of 29 over 29. Now for cosecant, I'm going to go back to this version of sine and flip this one around. So you have the square root of 29, square root of 29 over 5. The negative sign can go anywhere in the fraction. Up to you. All right, cosine. Cosine is x over r. So similar thing's going to happen here, guys. 2 over the square root of 29. And got to rationalize that. So you got 2 squared of 29 over 29. And then again, I'm going to choose this version of cosine to flip around. That's the square root of 29 over 2 for cosecant. And then finally, something nice happens. Tangent and cotangent are going to be beautiful. Tangent is y over x. So that would be -5 over 2. Cotangent would be the reciprocal of that, so -2 over 5. Now, one thing I notice is the only positive values we just got were cosine and secant. Everything else was negative. Was that supposed to happen? Look at what quadrant I'm in. Yes, I'm in quadrant 4. All students take calculus. Only cosine and his buddy should have come out positive there. So those of you who are prone to losing signs, this would be a good double check. Like, better just be cosine and secant who's positive. Everybody else should be negative. All right, I'm skipping that next one. This is not on your notes, but because we did skip number 8, you might want to jot this down because I think there's something like this on your homework. What if I asked you to find the 6 trig functions, or sorry, just one of them. Okay, whatever. 270. 270 is special because where's 270 at? Yeah, this dude right here, right? It's quadrantal. So if I think about any ordered pair here along this ray, I know the x value is 0, and the y value could be whatever I want it to be, but it has to be a negative value because you're moving down the coordinate plane. So to keep in mind, we're usually going to talk about the unit circle. I'm just going to call that the point 0, -1, so that way the length of distance is a 1. And if you weren't really thinking logically about this question and you were just robotically following your formulas and you went to go find r, you'd figure out that r was 0 plus 1, the square root of 1 is 1. And then I'd go, well, yeah, that's stupid, my bad. Because look, it's a unit circle. So how long would this ray be, or this segment? It would be 1. That's the definition of the unit circle. So here's x, here's y, here's r. And if I wanted to find the cosine at 270, and again, maybe I'm a robot and I only follow formulas. My new formula for cosine is x over r. So 0 over 1. And then I'd be like, oh, well, that's a 0. And then I go, duh, Mrs. Abruzzo. What's the x value in the unit circle? It's cosine. So that really should have been a very easy question for me. I don't even know why I did all that work. I should have, if I had my blue sheet, I should have just said, hey, 270, what's your cosine? And looked at the ordered pair. Now, what if I asked you for the tangent at 270? Well, tangent, and you got a couple formulas for tangent. Anyone want to throw me a formula for tangent? It can be the new one. It could be an old one from your previous life. Yes, the new formula is y over x. Otherwise, sine over cosine is the other formula for tangent, which is the same thing, right? So using our either formula, y over x would be -1 over 0. Y'all, what happens when you write an expression that says -1 over 0? It's undefined. So if I asked you for the tangent of 270, you would say it is undefined. So So the little bit of a bummer with using a unit circle reference page is, number one, you won't always have it. Number two, it doesn't tell you everything. Like, it has nothing to do with tangent and cotangent. You got to know your formulas for that. The reciprocal functions, you got to remember how the relationships work together. And guys, all of this only comes with practice. Your practice looks like homework. The review that we're going to give you for this test, which, you know, I probably should have given you guys today. Oh, well. It's not like a gazillion questions that look exactly like your test. We're expecting you to do your homework first and foremost, and then the review is just a set of extra practice problems. Okay? So I wouldn't care if you don't do every single question on the review as long as you did all your homework. I would be happy and you'd be prepared. Now, what happens if in our future, and this will happen eventually, you don't have a calculator, you don't have a reference page, and it says, quick, find the sine of 5 pi over 3. And you're like, what? All right, well, I forgot. I don't have it memorized. Whoopsies. I know it's one of the things, the square root of 3 over 2 or the 1/2, and I can't remember which one, and now I'm in a jam. Well, first issue is I have to figure out where 5 pi over 3 is, so maybe my brain would have to convert it. So 5 pi over 3, pi's would cancel, this becomes a 60, so this is 300 degrees. Now, if this is 300 degrees, and this is where you land, I don't really care about the 300 degrees. What I really care about is this angle right here. What is your reference angle? 60 degrees, right? 300 to 360. All right. So that's a 60 degree angle. Ladies and gentlemen, you have a 30, 60, 90. On the unit circle, I know the radius is 1. On a 30, 60, 90, I know the little leg, the shorter leg, is supposed to be half of the hypotenuse. So half of him would be a 1/2. And then the medium leg would be that little guy times the square root of 3. And look at me being all mathematically illegal. Yeah, I threw a negative on a leg of a triangle. What are you going to do about it? I need to put the negatives down, guys. Otherwise, I'm going to forget. Why is it negative, by the way? Because the direction, it's moving down. So, yes, I know it's not proper to call a leg of a triangle negative, but I do it anyways. So this ordered pair here is 1/2 comma negative square root of 3 over 2. So 400 years later, I can see that the sine is negative square root of 3 over 2. But this is what you would have to figure out if you're like in the middle of a calculus problem and you don't have a calculator and you don't have it memorized, or you're just having a moment where you're second guessing yourself. Mrs. Gupta is really a big believer in like memorizing those trig formulas before you even set foot in the calculus classroom, and you'll have a much smoother transition to calculus. Okay. However, good news on Tuesday, I won't be taking your reference page from you for this first test. So what we're going to do is we're going to practice like we're on the test. Okay. So we're going to be staring at our unit circle blue page, and I'm going to ask you to use your unit circle and quickly figure out all these values. All right. So let's go. Number 12, I think this is on your page somewhere towards the bottom. Cosine at 7 pi over 6. Well, first I got to go find 7 pi over 6. Here you are. Who's the cosine there? Yeah, very good. Negative square root of 3 over 2. Because that would be the xy, the x part of the xy ordered pair. All right, 13's a little tricky though. Okay, first of all, it's negative 3 pi over 4. So if you're not really sure where negative 3 pi over 4 is, what you could do is you could just convert it to a degree measure. Anyone know what that is off the top of her head, or at least what quadrant it's in? Oh, I just want to know where the angle is, sorry. Is it? It's right here? Okay. So this guy is the same thing as negative 3 pi over 4. So whether you converted it to degrees, thought really hard about that, or went like, oh, well, this is positive 3 pi over 4, so this would be negative 3 pi over 4, that's fine too. Either way, this is the angle we're looking at. And then I heard you guys rattling off the actual trig value. So the secant, what's secant again? Now I got to remember that. It's the reciprocal of cosine. So here's cosine for that value. I'm supposed to take the reciprocal of it. So it's negative 2 over the square root of 2. Math teachers don't like that answer, so now I got to go rationalize. And this comes out to negative 2 square roots of 2 over 2, which also reduces. And what happens? You get Negative square root of 2 over 2. Now, as you do your homework on this section, you're going to notice a whole bunch of questions. You keep seeing the same answers pop up over and over again. Negative square root of 2 shows up a lot. This is what we mean by practice, guys. The kids who choose not to do the practice, they're like suffering every single time they have to do a test question because they have to go and figure everything out the long way. It's not a good way to do the question. All right, number 14, tangent at pi over 2. Well, here's pi over 2. They don't tell me tangent. I got to think about that. Give me a formula for tangent. You can do y over x, or you can do sine over cosine. Either way, you end up with 1 over 0. What does that mean? Undefined. Very nice.
So then for cosine.
Oh, for that one?
Yes.
Yes.
Cosine could also be, well, I guess that would be way longer.
Make the triangle and stuff.
That's
Yes. R is 1, so the 1 doesn't really do anything. Yeah. Probably. And that's the thing with trig, right? There's always ways to get the answer, but is it going to get you? Is the test going to get finished? Is the issue. All right, cotangent of 4 pi over 3. So first of all, where's 4 pi over 3? There you are. So cotangent, I need a formula for cotangent because it's not one of my unit circle friends. You can either think of it as x over y or cosine over sine. Either way, that's cotangent. So where are we at here? X, oh no. X. How do you divide by a fraction? You multiply by the reciprocal. So I'm going to multiply by the negative 2 over the square root of 3. Oh no. Well, at least the negative and the 2's cancel. And I get 1 over the square root of 3. And then nobody's happy with that, because that's not rationalized. So real answer is the square root of 3 over 3. And again, this is one of those, like, after you do a bunch of them, you're like, well, this one's going to come out the square root of 3 over 3. Because you can tell, because you've seen this question 5 times in a row. Not a little bit. 5 times in your homework. All right, cosecant of 5 pi, oh, negative 5 pi over 4. Stinky. All right, so maybe I'm not really excited about measuring negative 5 pi over 4. Maybe I convert that to a degree measure. Well, guys, 5 pi over 4 is 225, so think about going negative 225 degrees. Wouldn't you end up right here? So, what do I want? Cosecant. Who's cosecant again? It's the reciprocal of sine. Think back to a couple problems ago. What's going to happen when you flip this and rationalize it and everything cancels out? You end up with just the square root of 2. By the way, the reason you're just ending up with square root of 2 is because the fraction square root of 2 over 2 originally was 1 over the square root of 2. Like before someone rationalized it, it was that. So if you were to flip that fraction that's non-rationalized, you'd get square root of 2. Cosine at pi. Well, here's pi. Who's cosine? Negative 1. Very good. Oh boy. Cotangent at 270. Here's 270. Here's my ordered pair. Cotangent, which formula do you want to use? Yeah, I like that one too. All right, x over y. No, don't panic here. You can take 0 and divide it by negative 1. What do you get? 0. Very good. Sine at 90. That's up here. That's a 1. Tangent at negative 60. Okay, well, negative 60 would be like this way, right? So it's right here. Uh-oh, tangent. Okay, yeah, is what I see too. So tangent is sine divided by cosine, or y divided by x. So negative square root of 3 over 2. I'm going to divide by half, also known as multiplying by 2 over 1. Well, this one's not too bad. You just end up with negative square root of 3. Yikes. Aren't these fun? These take practice, guys. It's nice because a lot of kids are like, oh, thank goodness, she's giving me the unit circle. So it's going to be really easy, right? Yeah, it turns out no. Because you got to practice these. I want full transparency here, guys. I'm calling people at home if I don't see homework. If you have no homework and a bad test score, you're getting a talking to, children. I'm still going to give you a talking to because that's dangerous, slippery slope you're on. All right. Your homework for tonight is on the back of worksheet 7B. She copied the bookwork for you, even circled the problems for you. She's so sweet.